Okay.
Okay, you can start.
Yeah, sir. Is it visible?
Yes, ma'am. Yes,
Okay.
yes.
Okay, today we'll discuss about the supervised machine learning approaches and one of the supervised learning approach, that is linear regression model. Okay. So, as we explained in the previous task, supervised machine learning method involves the level data set and will train a model. The purpose of the model predict the output according to what is the input values. This thing I already explained you. So, moreover, in the supervised machine learning, you are creating a model that is a mapping, and the mapping is from the features value to the what is the level value. Level value is a function of the features values. Okay, input features value, you can say. Then after from the data set, you will create this mapping, this model. Then when a new input data features is given to you with the unknown output value, if you give the input features value, it will give you the output value. Okay. So generally the output value can be categorical values or the continuous values. Okay. So according to that, you can say, here is the example I already gave you. This example, this is the categorical value. That is A is snow, like this, and in the under continuous values is these are the 30.5, 55.0, like this. You have the continuous level values. So according to this levels value, you can say the prediction value. The supervised learning approach is two category. One is the regression, another is the classification. If the level value is the continuous value, that means your output value is the continuous value, then you are saying that you are creating a regression model. And if the output value has the categorical values, then you can say you have created model, supervised machine learning model, that is the classification models. We have so many types of supervised machine learning model, that is for the regression as well as for the classification. Some specific models is there that use for the classification, and some specific models is there is for the regressions, or some models is there is used for both classification and regression. So first of all, we'll go how mathematically representing that features values. Okay, you see here, this is the data set. Here the classification data set is the left side. Here what's happened, you have the features value, 4 features value, and corresponding level value is this one. And correspondingly, mathematically, you are symbolized like this matrix form. You are saying the features, weather is xi1, temperature is xi2, humidity I3, and wind xi4, and the level value play is stand for yi. And correspondingly, you can see the elements as x1, x12, x13, x1, like this 10 instances, corresponding 10th name is given. Same is for the regression. You have here the 2 features and 1 level data. yi is written, y1, y2, y7, and performance is here the year of experience is xi1, performance is xi2. Correspondingly, elements you are saying the x11, x12. Generally, like this it is interpreted, so that mathematical calculation is performed for the creating the models. So These things I already explained you. You have this data, and with this data, you are making a model that is supervised machine learning model, and the purpose of the model is to predict the Y. And you get this model using this training data. Okay, using this data, you are getting the trained model. And when a new data is given to it, this model predict the output. Okay, that is the purpose of the supervised machine learning. So in the linear regression model, what happens? You have the features value, as I said, you x1, x2, xp features values, and from the you will create a model. The model is like this: y is equal to beta 0 plus beta 1, x1, beta 2, x2, beta p, xp, and some error is there. This error is fixed. Some error you must find here. Okay. So here was happened. This x1 are the features value of the, and the y is your prediction value. This one. And in your data table, you see in the data table, you can say x1 is this one, x2 is this one, this is your y. So like this you have, and this x1 and x2, xp, how you get, you don't know. They are the independent variables. It's get somehow. And here the y is the dependent variable. Y depend upon the value of x1, x2, xp. Beside, it also depend upon the beta 0, beta 1, beta 2, up to beta p. And these are called the regression coefficient. Beta 0 is called the intercept values, and some error must be arised there. Okay, so you have to minimize that error. So how to find this value, this beta 0 to beta p, and this how much error will be manageable error you will find. How you find this values? You will find this value using that model. Now our technique, our work is to find out this beta 1, 0 to beta 1 up to beta p value. What should be this value? This value can we find out from the given data. You will train this beta 0 to beta p value using that training data set. Okay. So there is so many mathematical model. Some also learn the regression model in the statistic. You have learned that one. And using some mathematical techniques, so many techniques is there. You generally the least square method is there. Using that one, you can find this beta 0 to beta p with the data. You use the least square method as well as the data set. Then only you will find the p plus 1 number of equations, and from that p plus 1 number of equation, when you solve that equation, you will get this coefficient and the intercept value. So here this linear regression model purpose is to, this is the model. Your model is y is equal to beta 0 plus beta 1 x1, beta p xp plus some error. Your purpose is to find this, the model purpose, this one is you will write the algorithm to find out this beta 0 to beta p values for the data set. So that when a new data set, this value is find out from the training data set. And when the new data set will come, you have only this x1 to xp value. You will use this model and find out the y value. Okay. So linear regression model is this one. So solving this using the vast amount of data, solving this beta 0 to beta p value is not a small task. You may not able to calculate. You cannot able to calculate using your copy, even if the computer. So you need to use the algorithm, some mathematical process, step-by-step process, that is called the machine learning algorithm to find out these values. Okay, that is called the least square method. Some numerical analysis method is also there to find out that value. So you'll use that one and find. But now you are not required to do that one because you already it's very difficult to calculate here. You can use your Python library and you can find this beta 0 to beta p values. So here you can say why is the prediction output, like if you are from the, the year of experience and education level, what is the salary that I gave the example here, this one. Here you are year of experience and the performance. From this you will find the salary. That means here this is your Y and this is your X1 and this is your X2. Okay, when you give this experience and the performance, it will show you what will be the salary of your portions. So then is understanding the relation between the variable and Y and X. What is the relation? That means you have to find the beta 0 to beta p value. Controlling for multiple factors simultaneously, difficult to how much you will consider, how much should be the coefficient. This one is manually finding is a very difficult task. You can do only by using the math calculations. Then your this linear regression model have some. You cannot use these models everywhere. You have to use in the specific case when the features value x1 to xp, the features value linearly related to y value, not non-linear relation. That is the linear relation. Linear relation means you are multiplying beta with the x1, beta with the x1, then only you are finding out the y. There is no higher degree of x1, x2. The degree 1, 2 will be there. That means there not be x1 square or x1 cube, x2 square like this. Non-linear relation, there will be no non-linear relation. That must be linear relations. Then only you can use this model, and then only it can give the good result, accurate result, less error. Otherwise, if they are not linearly related, non-linear relation between the target value and the y value and the features value, then this model will not work better. Okay? It failed to predict the correct answer. So relation between so you can say the relation between the predictors. Here the predictors means x1, x2, xp features, and response is your y is have linearity, independence. And x1, x2, x up to xp, these values are independently you are finding. You are not going to consider here in the algorithm x1, xp value are not considered. Whatever you will enter, that will not change. That must be constant here. It's independent to algorithm. So it is whatever you are generate and give to the algorithm, it will kept. It will be kept. It will not change. Only the coefficient in this beta 0, beta 1, beta 2 up to beta p value will be changed. Then is homostaticity, that is constant variance of error. When you final model, when you get after getting this beta 0, beta 1, beta 2 to beta p value, you must have some error, and that error must be some amount, that must be minimum value, and how much it is tolerable, that value will be there. That means you are saying that if there is 90% accurate or 99% accurate and your error is 1%, then it is manageable. Then you can able to predict. Suppose you are saying that in case of the regression, the value is your value, accurate value is 20, but you are getting the prediction is 19. It's okay. One error is okay, but difference is one is okay. But if you are saying that the error is your prediction is 10, but accurate result is your 50, the difference is very large. So it is not tolerable error. So error must be between that. You can say error will be lies between -1 to 1, or you can say 0 to 1, or you can say 0.009. Error, if there is error this much, then you can take that is the correct answer. Some error, some amount of error will be defined to you. And that is normally this way. Whatever you will predict the value, so for different features, you are getting the different y value. That error must be some amount, that is fixed amount, range, between some range. Normality will be there. Okay? So no multi-collinearity. That means they are not highly correlated. As I said you in the point 1, that is linearity relation. That is the degree of this features value must be 1. Degree is 1, not square, cube like this. If it is non-square, cube, all this, that is called the multicollinearity. Okay, not they are not highly correlated. Again, it is given that the predictor are not highly correlated. Predictors means, what is the predictor? X1, X2, X3, all are the features values. And these features value are not highly correlated. Highly correlated means whatever feature you will take, they are independent to each other. Okay? They are independent to each other. You cannot express x1 is equal to 2x2. If they can be expressed like this, then you can say they are highly correlated. Okay, you can write x1. What is x1 is same as x2. If you write like in the matrix, if you remember the matrix concept, if you are multiplying 2 to a column, you will get another column. And if you learn about the basis in the linear algebra, then you can able to understand what is the independent variables. So here you will find the features are the independent. If they will go highly correlated, then this model will not work. It predicts 0 always. Okay. So you cannot able to, you may not predict the 0, but you cannot able to find this using this model. When you use the mathematical least square method to solve this one, you will unable to solve this one, because some value will be not find out due to this dependency among the variable, collinearity between the variable, it becomes 0. Okay, some value becomes 0. That's why the features must not be collinear. They don't have the highly correlated. You cannot express one features in terms of another feature. If you find such a form, then you have to remove one feature in that case. Otherwise, you cannot generate the regression. So this is about your linear regression. I'm not going into inside the mathematical derivation. I'm just giving you an idea. Now let's implement all this, how we can implement. So I have too much time for the implementation. We'll do the both yesterday and tomorrow lab. As I explained you in the previous class, you have to find out the Google Colab. That is the, is it visible? Is it visible? Hello? Is it visible? Okay. So let's see how we implement this model. Uh, if time permit, I'll go for the next model. Otherwise, today we'll complete with this. So your site is HTTP. Backslash Colab. It's already there because I opened this one recently. Okay, create a new. It's come. The name of the lab 3. So let's start. As I explain you first, in my system, that is for the regression data. Since you are using the linear regressions models, this is a regression data. It is a price of a house prediction. Very simple data set. We will go to the very little complex data set later. And first of all, since we are learning, we will go through very simple data set. This is the data set. Well, this is your label data. That is the price of the house. And here, how much square feet house built is given, square feet. Then this is your how many number of bedrooms is there. Then you are finding the how many numbers of bathroom is there and how many floors is there, 1, 2, 3, 4 floor. Then what is the year of building of house, this, that is the age, and what is the location, is it urban, rural, or suburban, like this. Then what is the prices given to. Okay, these are 100 instances, 100 instances here. And first one is your label, so it is showing 101. It is the starting from the 2. Okay. This is the data set, and you are finding that the some data set is missed here. You see this one is missed, this one is missed, this 2 is missed, and some data set is also missed here. So if you have the data set having some missing value or any string value, this is the you are finding, then you are on it. You cannot implement this regression model. The regression model I described in this one, since you are doing the calculation, you are using the least square method, you are finding the numeric value. This x1 to xp value must be the numeric values. Okay, and since here the data set is your some data set, this data set has the string value, again there is so many data set is absent here, missing here, so you cannot able to you, because if you have this missing, you cannot find the equation, least square method equations, and there will be error in calculation. So you must include the value here again, since these are the string values, so you must convert it into the numeric form that I taught you in the yesterday class. You have to you have 3 type of encoding approach. You can encode this string data. So how you will do this one? Before using the ML approach, you have to pre-process the data. That is, first you have to, as I explained in previous class, first you have to do the data analysis. Then you will do the exploratory data analysis. Then you will use the pre-process approach to in the exploratory data analysis. What you will find where is the missing data, and what is the abnormal data. All this information you will try to find out, analyze the data, how the pattern of the data, on is there any outliers or not. All this information you will try to find out using the data analysis. Then you, according to what you find, what change need to be do, then correspondingly you will do in the pre-processing step. Okay. Then it will be ready for the using the regression model. So let's do with this data. Okay, this is only 100 data, but in real life you may get the data in TV, which even not able to open in this system. You need the high performance computing or high level memory. So first this file will be uploaded to Colab where you will work. How you load this file? The file name is regression underscore data. How we load this one? You, the syntax I already explained you. Also, I have given you the PPT in two ways you can load the data. One is you will directly load to here to the Colab. Second form is you keep your data inside your drive, Gmail drive, then Google Drive, then you call that data from the Google Drive. The two way. Then first of all, I am explaining you how you upload the data here, and you can upload the data here if the data set is less number of data. So otherwise, if you have the high amount of data and you have to keep it in the Google Drive so that it will be easy to, it will take less time, because you have, if you use here from you upload here the data, it will take the time. Directly, if you already keep the data in the Google Drive, you directly use that one, it will take less time. But if you will fast upload here, that is vast amount of data in TV is difficult to upload here. Google Colab will not. So how to upload here in the Google Colab? Let's learn first. That is your input. Okay, we first will Google, let call to the form Google Colab. Colab import files. Okay. Then use this one, upload your files. That is files dot you have imported from the Google Colab directory folder. You imported the files, then files will help you to bring the data. Files that upload. It has a function called upload, and through it you will get this data. So when you run this one, it will ask for to load the data. It is running. Choose here. So here I am taking this regression data file and opening here. If you when you choose the files, it will show you to upload the file from your system. Then you have the regression underscore data file. I just upload this one. Then you will use this file. How you use this file? You can use this file using the pandas library. So first of all, you have to import the panda libraries. Okay, panda library, and I have given the name of the panda library as PT. Then you will suppose you have the DF. DF stand for data file. I have given the name DF. Then I read the data set PT dot using the pandas. I did dot underscore CSV, since it is the CSV file, the command is like that. Then you have the, what is the name of this one? Regression data dot CSV. Just copy this name and put here. All the contents. You just can see first 5 contents or last 5 contents using, or any range of contents according to your command. Here I have write the command to see the first 5 contents. See here, after running, you will find out that the first 5 contents, 0, the index of the first instance is 0. Then 1, 2, 3, 4. Okay. See this file, it is matching with it. Yes, sir. Okay. This is the first 5 contents, you can see. Besides that, you have to find out other things. In the drive, then you can call and use it. Only the difference is that no much more difference. You will save the data in the drive, your Gmail drive, Google Drive. Then instead of writing here the files, you will write here the drives. Then you will upload for drives.upload. Then you will it automatically come to the same command. Then you mount, first you will mount the drive, then you will call this one, you will find same procedure. Only the difference is that instead of writing this command, you will write the some mount command. So we'll discuss when I'll do another model, I will discuss how you will load the data here from the drive. Today we just learn how you will upload the data directly to the folder. So next, season is it is in the form that you can use that data to machine learning. You can use the machine learning or not, you have to find out. Okay. For that, you have to check whether there is any missing data or not. So let's see, first of all, how you find out the missing data. Is there any missing data? So if you want to find out the safe of the data set, you just write DF. DF is your data file, this one. This is the data frame file. If you want to find out the safe of the data file, just write df.safe. You will find how many rows and how many columns inside it. You find here the number of rows is 100, number of columns is 7. Again, if you want to find out the columns name only you can write df.columns. You will find the column names are AR, area, square feet, bedrooms, bathroom, floor, space, location, and the price. Then let's go for the whether there is any missing data is not. Another thing, you can also find the data types, how many missing data is there. How can find df.info. Info, you'll do the bracket. Then when you run, you will find all the information. See here, you have this seven attributes, and correspondingly this area square it 100 is there, bedroom is 100, but bathroom is 88. That means 22 data are missed. And age is 92, that means 8 data is not there. Location is 90, that means 10 data is not there. Okay. So number of data available now is given to you. If you want to specifically know which are the missing data, how many is df dot is null. Is null. So you see here, you find area has no data, no missing data, bedroom, bathroom, floors have no missing data, age has 8 missing data, bathrooms has 12 missing data, location has the 10 missing data. We also verify here also by doing the subtract from the 100. So in this way, you can find again, if you want to remove this no is some null data, you can remove this data, or if you want to replace some other value, mean value or mode value or some value, you find out that it should be, the value should be this one, you can keep that value in that cells also where it is missed, then the missing problem will be shut out. Okay, you have to put the values there, either mean, median, mode value, or any value you are feeling that it is suitable there. You have to analyze the data, which type of data it is, and correspondingly what should be there, you can fill. Then you have to find is there any duplicate account? We'll know how you replace when you before starting to implementing the ML relation models. Yeah. So here I am explaining you how you find the duplicate data. Is there any duplicate data? You'll write df duplicated. Okay. This one dot how many duplicates data is there? No duplicate data is there. It is giving 0. 0 means that is no duplicate data. If there is duplicate data, you can also drop the duplicate data. Suppose in the this one you find the same data. So what you will do? You have to same row or same column, then you can drop that data. You can write df dot drop, drop, then duplicate, duplicates. If you write this one, you don't have the duplicates, so no, nothing will happen. Since that is, if there is room and it is so how many data 100 to 7, no duplicate is there, nothing is deleted. The data is same as it was. Okay. So next we'll go for next we'll go for to plot the data. What is the, how many data is, how many types of data. You can do the bar diagram to observe the data pattern or analyze it. You can draw the histogram or the bar diagram, and to find out the outliers, as I explained you in the previous class, what is the meaning of outliers, and to remove that outliers, you can find out using the box plot. Okay, so how you draw the histograms of the, suppose you want to draw the histogram of the square feet, then how you draw, what is the syntax? First of all, you will import the library, that is your matplotlib. Matplotlib dot pyplot. Another also, you can import cbond. Import these two are used for the graph plot. Okay, cbond. dr. If you want to draw the histogram for the square area, you will write here the square area. And since it is a string, you have to keep inside this column. It may be one column or two column, or it may be a three column. Okay. This is the name, and you want to draw the histogram taking the data, so you will write dot hist. When you run this one, see, you are finding the area is from here the minimum area of is here how much 750 to started. It is maximum is 25,000 something, and between that how much is how much instances is of how many area is defined. This is how much instances, and this is the area. Okay, so this is from between the 0 to 100. If you add all the, you will get the 100, because you have the 100 distance here, 100 instances here, and the area is between the 750 to 2. Again, another thing I have forget to say you, that you can see the description of the all the data. If you want to find the description of all the data, you can find also numerical data that what is the maximum value of it, what is the minimum value of it, and what is the mean value, median value. All this you can find out here. If you write the command df dot describe, if it's describe, you will find about the numeric data, information about the numeric data. See here, your square areas, square feet is your numeric, so is count 100 time instances, so 100 time. Mean value is here, you add all the area and divide with the 100, you will find these values. Mean square feet, standard deviation 549, and minimum value is 807, and maximum is 2627. Okay, and this is about your, this is maximum, this is minimum. 150% value is this one, 75% value is this one. And so accordingly, you can find out what is the minimum value or the mean median mode also you can find by giving the command. And accordingly, you will fill the value and you will consider the value or you will normalize the value. Okay. So this thing can be find out using the data analysis. You do the box plot. What is the box plot? Box plot is so the model you train with the data will not give the better result. So what is the command? SNN box plot df. Suppose you want to give the box plot of your area. Square. If you run this one, you will find the box plot. You see here, this is the box plot. And you see this value here, any value you will find here, and more than this one, then you will remove that. And any value come more than this one, you will remove that data. Otherwise, if you train with this, that instance should be omitted. Otherwise, if you train your model using that instances, you will get a abnormal model. Okay, it will not give a better prediction. It may be underfitting, the problem of underfitting, or you may get the overfitting like this happen. Generally, you will find a underfitting. So that means you will, if any value is there, you have to find this value, these outliers, which is more than this value and less than this value, you have to remove this. So this is about the box plot. Then the heat map. Another is the correlation value. Correlation means what is the relationship between the features value. Ajay explain you that the feature values must have some collinearity. Okay, so this criteria is very important for you. That means you already, if you know already correlations value, correlations means the degree of relation lies between the -1 to 1. If you find it is very close to 1 relation, then they are equal. They are highly correlated. That features, so if they are highly correlated with the target value, then it is better to keep the features. If it is highly correlated to other features values, then you have to remove one. Okay. So otherwise you will not get a model, good model. So how you find the relations value? By plotting the correlations value. You can use the C1 library to plot this correlations value. The syntax is SNS dot heat map. This one, heat map. And df data file, df correlation. And you have to write here unknown. Unknown means it will keep, it will not remove. Whatever interpretation you do with it, whatever result you find, it will be so. So there is some error. SLS. Some error is here. df dot okay, what is the error? Let's see. Stream to flow forward. Okay, it's saying that if there is any correlation value, is a coefficient correlations value, you will calculate with the numeric value. You cannot calculate with the category string value. So since in our data set that is some category string value, you see here in the data set you have these are your string values. So it is unable to calculate and showing the error. So you only calculate the correlation value for the numerical value. And if you want to find out the correlation between this string value with the target value and the other value, then what you have to convert it into the numeric value. So you can use the encoder to convert this value. We'll see now how you use the encoder. Okay. So here you have to write. So only for considering the numeric value, you have to write inside the bracket as numeric only. Okay. If you write here numeric only, it will work. Still, that is somewhere. Still, numeric only is not even. Is equal to 2. Now you find the correlation. That means you see here, since the string data, this one is your location. Location is not plotted here. The other are plotted. 1, 2, 3, 4, 5. You have the 7 features. Now it is 6 features since location is not there. So when you see here, area square feet to area square feet relation is 100% because they because they are decreased and their value is always correspondingly same. But with the bedroom, it is 0.14. For the bathroom, 0.079. For the floors, 0.16. For age, 0.13 with the area square feet. For the price, 0.98. Since it is, for the price is high, very nearer to 1. Very close to 0 is better for the features, and very close to 1 is better for the label. Our label data is price, other are the features. And you are finding that the scope area square feet features highly related to price level, and but it is lower related to this 4. With itself, it is a good relation. So obviously it will be 1. You see here, this angle is all are 1 because price related to price is always 1. If you multiply price with 1, it will show you itself. So price related to price is same, that's why it is 1. And age related to age is 1. So you will find this angle is all are 1. Other are related to how much relation is find out. Okay. So this one is same as this one. You can only see this either this lower triangle or you can see this upper triangle portion, and you will find the what is the bonding between them. The here you find here in the bedroom case you find that with the price the bedroom is very less related. But you can take they are related. If it is not 0 means they are somehow related. But if it is very close to 1, then you will find that it is highly related. And if it is not very close to 1, you see here, age is not very close to the price. That means age is not related to more to price. So in this way, you interpret, and when you find any 0 correlation value here, that feature you can remove. 0 correlation with the target, then you can remove that features value. Again, another thing is that if you find between the features value, suppose bedrooms with the age, the value is 1 or very close to 1 or -1. -1 means negatively related. +1 means positively. Positive means if 1 is increased, another will increase. Negative is if 1 is increased, another will decrease. So if they are high, very nearer to 2 or 1, value is 1 or -1, you can remove one feature, any one features from the data set. Okay. So this is about your correlation. After this analysis, we find out that there is no duplicate data is there. And again, we find out that some missing value is there. Another thing is find out that one location is not used to calculate. So to regression approach, linear regression approach, you have to sort out the problem of missing values. Another is to convert this location into the numeric value. So let's do these things. Then we'll use the multiple. We'll use the multiple linear regressions. So first of all, we'll remove the missing. So for that, what you can do, you have a facility in the Python coding system, that is a pipelining. We combine the two things can be do. One thing you can do the put some value if there is any missing value, and you can input the categorical values into the numeric form. All this you can make a pipeline of doing this one. Then you directly use that pipeline on your data set. First of all, let us consider for the numeric data. You will create here numeric. pipeline. Pipeline. Oh, yeah. One thing is important before using the pipeline in the model, you have to load that uh, file inside. So the syntax is from you have to before using the multiple linear regression approach, you need to import some files. That is, one is your panda file is already import. Another, you have to import the numpy. One is numpy as np. Next, another, you have to load the uh, uh, pipeline from import pipeline is already given. Coming here in the Colab. Colab, you can get this user-friendly form. Pipeline. Another, you have to load the imputer. Okay. From is for Escalon. You can directly do all the missing value, sort out the missing value and everything in the data set, or you can combine all these things, whatever you do in the analysis, what activities need to do, you just find out and do combinely, make a preprocessor and do combine it all the command, then use on the data set. It also possible. Let's do. So impute import simple imputer. Simple imputer. Next, after since you want to convert the numerical data in a form from 0 to 1 form, so you have to use this library which automatically do standard scalar. That means all numeric value will be mapped to the between 0 to 1 or some value range. All numeric. That is 6 numeric features is there. All 6 numeric features will be converted between some range, same range. So that model, you can get a good model. Another is the one-hot encoder. One-hot encoder means it will automatically convert, this library will convert your string data, that is the location data, into the numeric form. Okay. Then another is the you have write a escalon.compose import. That means we'll combinedly do all the work, whatever preprocessing activities needed, like to sort out the missing value, doing the transform the numeric value between 0 to 1 and converting to the categorical value into the numeric form using a one-hot encoder. Whatever activities you want to do, you can combine it as a one preprocessor and you directly imposes on the data set so that it automatically do everything. You need to do anything else. Okay, so this is your, for that you can use the column transfer. Okay. So next you will use the linear regression model. In the sklearn there is a linear model class is there. Inside there it is defined. They are defined the linear regressions. Okay, we can use this linear regression and the to implement the linear regressions model. Okay, find out the linear regression model. So now let's do work with it. Whether all the syntax is wrong or right, you can find out by running this cell. Okay. Next is your, after that we already load the data set and you will keep the features value in one data frame. So you can write df dot, you just delete the price here, price of the house here, drop the price of house. Then you keep all the drop means it will drop the price column. Here I have target column you have separated from your features. That. Axis 1. You will write here axis 1 means it is the column. It is showing that curve. If you write 0, so drop the fast row. Okay, if you write the axis 1, it will delete the price column. Okay. So then you will keep the, you will take y as your only keep the target data. Okay, that is your price. With the syntax is right or wrong, you can run it and find out if there is any error. You can next you will sort out the features of the problem of the missing data and the encoding to numeric form. So first of all, let us consider for the what are the numeric features here. The numeric features here is, I'm giving a numeric features name as variable name as numeric features. It's your inside the X you have dot select data types. That is include only numeric data. Numeric data means your integer and the float data. So you have to write here int 64 because it is Python is of 64 bits converter. So next is your float 64. Okay, all numeric data will be stored here. This way, is it working or not? Select data to include. Yes, it is selected. Then you can take the categorical data as cat features. Cat features. It's same, whatever written, only is that you have to write here the offset. You have to write here the offset. You can see here, you see here in the data description. Let's see whether it is working or not. Yes, it is. It is right. Next will it is will the convert it this one. First will convert the numeric data. When that is missing data, just put there the mean value. Okay, here I am putting the mean value. You can put according to your choice, your requirement or suitability. Pipeline. Imputer, simple imputer. You have already do the simple call the simple imputer library from the sklearn. Ever simple imputer strategy is your mean. So you will, by calling this one, what you are doing, you are whatever the data is missing, you will put there the mean value of that column. Strategy is your mean. Simple. It is missing here. Is there any spelling? Loss. Okay, let's see what is the it's not defined. Define we have defined a simple imputer. Here is I is greater. On this one. Okay. Next, another you will doing the doing for the categorical value, that means will encoding it into the uh, into the numeric data. Then if any miss value is there, you will use that the mode value. Okay. So same you will write here, whatever is written here, just this little change will be there. So instead of new, you will write here the categorical value, CT, then imputer, then write the pipeline imputer simple strategy is most frequent. Okay, strategy is here most frequent. Okay, next is you will do the here only. You are not dealing with the missing value. You are converting the data to encoder to one hotline. One hot encoder. Okay, one hot encoder handle on this. Yeah. So this is the syntax. Let's see whether it is working or not. Any error is there? No, yes, there is no error. Okay. So we'll apply these two things to your data set. So you'll combine first these two, then we'll combinedly use on your data set. How you combine this one? So as I explain you will use here we'll call the function column transformer, use that column transformer and combine this. It's already written here. Inside this one. Well, transformer. Num numeric first you will do the numeric one, so you can write the norm, then you can write the norm pipeline. First norm pipeline, this one underscore, you already declared this one pipeline. Next you will do the features, it will apply on the norm features. Then next is for the categorical. Write this the cat. You can write the cat or you can write the categorical directly. Then what is the pipeline we created? Cat underscore pipeline. Then you have cat features. Apply this. there in the let us find. What was your data set? Your data set is X. We already keep the features value in one set and the target value in another set. See here we what is the cell we have down here? X is only the features, Y is the target. Okay, so on the X you will apply because for the features you are considering. In the target you don't have any problem. So how do you apply this one? Just write here.
Ma'am, time is 1 o'clock.
Okay, sir. So next, just going to complete in 5 minutes.
Because you informed me to leave,
Yes, sir.
some work is there, that's why.
Okay, then we'll start on the next.
And
tomorrow.
share this particular collab notebook to others with permission, so that others can also practice. Because without practice, it's not possible to understand. Okay. And all of you request us practice, and I think in the beginning, first we'll clarify the doubts of the student for 10 to 15 minutes. Okay. Then only we'll go for the theory.
Okay.
I think you can stop
Okay,
now
next
because
class
you
we'll
have
first
exam
start.
duty. You have exam is there, that's why.
Yes, sir. Okay, sir. So tomorrow we'll discuss how you implement these things on the data. Yes. Thank you. So tomorrow is same time?
You tell, same time or 12 to 1:30. What time is suitable for you? Tomorrow you have exam?
No, I don't have exam.
Then at what time we'll take then? Same at 4:30
tomorrow
or?
No,
And then
tomorrow I
what time
don't
we'll
have
take?
an exam. Yes, this time is suitable. I don't have any problem.
Okay, so at 12, okay, at 12 we'll take. 12 to 1:30.
Okay.
Or 11:30 is okay.
Okay.
Students, who tell? Let ask the students. Which time is better? 12 or 11:30? Yes, you can unmute. 11:30 is fine. Okay, fine. Done.
Okay.
Okay, thank you very much. You just share this axis, Google column, and give the axis so that student can practice.
Okay, I'll send you the data set.